In late 2023, China did something no nation in history had ever done. Quietly, with almost no Western media coverage, a Chinese aviation authority handed an airworthiness certificate to a flying vehicle with no pilot inside. No cockpit, no manual controls, no human override, just a sealed passenger pod lifted into the sky by 16 electric rotors, guided entirely by software. While the United States was still drowning in FAA paperwork and Europe's aviation regulators debated safety frameworks, China skipped the line. Its autonomous air taxis were already carrying real passengers over real city skylines. Not in a test facility, not on a closed course, over live, populated cities. And what happened next set off a chain of events, technical, financial, and political, that almost no one outside the industry fully understands. Because beneath the sleek promotional footage and the government press conferences, engineers, investors, and critics have raised serious concerns. Concerns that could either be growing pains of a trillion-dollar revolution or warning signs of a catastrophe waiting to happen. If you're fascinated by massive engineering breakthroughs in the future of transportation, make sure to subscribe to Next Blueprint, like this video, and drop a comment telling us whether you'd trust a flying vehicle with no pilot. Now let's get into what's really going on. The vehicle at the center of all of this is the EHang 216S. And the first thing you need to understand is what it is not. It is not a helicopter, it is not a drone, and despite what headlines love to call it, it is not a flying car. It is something entirely new, something regulators had to invent a category for. EHang calls it an autonomous aerial vehicle, or AAV. A small egg-shaped cabin sits beneath a canopy of 16 electric rotors arranged in 8 arms. 2 passengers climb inside, close the door, and tap a destination on a touchscreen. That is the full extent of human involvement. There is no joystick, no steering wheel, no throttle. The vehicle lifts off, navigates its route, adjusts for wind and obstacles, and lands, all without a single human input from inside or outside the cabin. In October 2023, China's Civil Aviation Administration, the CAAC, granted the EHang 216S a type certificate. That might sound like bureaucratic paperwork. It is not. A type certificate means a national aviation authority has reviewed every system, every sensor, every failure scenario, and formally declared this machine safe to carry human beings. No pilotless passenger aircraft had ever received that designation, anywhere, from any country. China did it first. And within months, commercial flights launched in Guangzhou, Hefei, and Shenzhen, with tourist sightseeing routes carrying paying passengers over urban waterfronts. The world barely noticed, but inside the aerospace industry, the shockwave was immediate. And the reason it matters goes far beyond one vehicle. Here is what most people misunderstand about this story. China's lead has almost nothing to do with having better engineers or more advanced technology. American companies like Joby Aviation and Archer have been building eVTOL aircraft for years. European firms like Volocopter and Lilium have flown impressive prototypes. On raw engineering talent, the West is not behind. The gap is not in the labs, it is in the system. China's centralized government operates on a completely different timeline. When Beijing identifies an industry as strategically important, it aligns regulators, local governments, manufacturers, and infrastructure builders simultaneously. There is no years-long public comment period, no layered federal and state jurisdictional battles, no congressional hearings stalling funding. The CAAC worked directly with EHang throughout the certification process, streamlining reviews that would take the FAA 5 to 7 years into roughly 2. At the same time, Chinese cities began constructing vertiports, urban landing pads with charging stations, before the aircraft even received final approval. Flight routes were mapped, airspace corridors were designated, commercial pricing was tested, all in parallel. Compare that to the United States. Joby Aviation, widely considered America's most advanced eVTOL company, has been flying prototypes since 2017. It is backed by Toyota. It has over $1 billion in funding, and as of now, it still does not have FAA certification for commercial passenger flights. Archer Aviation faces a similar timeline. In Europe, Lilium filed for bankruptcy in late 2024 after running out of cash before certification, and Volocopter has repeatedly pushed back its commercial launch. China did not just win a technology race, it won a bureaucracy race. And in aviation, that might matter even more. But speed comes with trade-offs, and the engineering questions that China's rapid timeline may have compressed, not eliminated, are exactly where the real risks begin. Strip away the marketing, and the core proposition of the EHang 216S is staggering in its ambition. This machine asks passengers to trust their lives entirely to software. No backup human, no remote pilot with a joystick watching from a control room. The onboard computer system must handle every conceivable scenario: wind shear, sensor failure, sudden weather changes, bird strikes, GPS signal loss, completely alone, in real time, with human lives in the cabin. The flight control architecture relies on sensor fusion. Multiple redundant systems, LiDAR, GPS, inertial measurement units, barometric altimeters, visual cameras, feed data into a central flight computer that continuously calculates the vehicle's position, speed, altitude, and orientation. If one sensor fails, others compensate, in theory. But engineers have quietly raised concerns about edge cases. Dense urban environments create GPS multipath errors, signals bouncing off skyscrapers and arriving at the receiver with corrupted location data. Heavy rain or fog can degrade LiDAR accuracy. Electromagnetic interference from cellular towers, power lines, or even other aircraft can disrupt communication links. And then there's the battery ceiling. The EHang 216S runs on lithium polymer batteries. Current energy density limits the vehicle to roughly 30 kilometers of range and around 25 minutes of flight time. For a scenic tourist loop over a waterfront, that is adequate. For meaningful urban commuting, the kind of city-to-city travel that would justify the revolution label, it is nowhere close. Battery technology is improving, but slowly. The kind of breakthrough needed to double or triple range without adding prohibitive weight has been 5 years away for the last 20 years. None of this means the technology cannot work, but it does mean the gap between a controlled demonstration flight and reliable, all-weather, mass-scale daily operations is enormous. And the industry already knows what happens when that gap gets exposed. If this is changing the way you think about flying vehicles, hit like so more people can see this breakdown. Every promotional video shows the same thing: smooth liftoff, gentle cruise, perfect landing. What you never see is what happens when things go wrong. And things have gone wrong. In 2023, footage circulated online of an EHang prototype crashing during what appeared to be a test flight. The vehicle lost stability and dropped from a significant height. EHang never issued a detailed public explanation of the root cause. The incident was largely scrubbed from mainstream coverage, but within engineering circles, it raised sharp questions. Was it a software error? A sensor malfunction? A battery fault? Without transparent incident reporting, no one outside the company can be certain. And EHang is not alone. The broader eVTOL industry carries a trail of incidents that rarely make headlines. Joby Aviation experienced the crash during a remote test flight in 2022. The vehicle was unoccupied, but the NTSB investigation revealed a component failure that required design changes. Lilium dealt with a prototype fire at its testing facility. These are not unusual for experimental aviation. Every aircraft program in history has encountered failures during development. But autonomous passenger vehicles face a unique vulnerability that traditional aircraft do not. Public perception. Commercial aviation is statistically the safest form of transportation on Earth, but it took decades of transparent accident investigation, published safety data, and a visible human pilot in the cockpit to build that trust. Autonomous air taxis have none of that history. One widely shared crash video, especially one involving passengers, could trigger a public backlash that no amount of statistical data can reverse. Reports suggest that regulators are acutely aware of this dynamic. Some experts believe the industry is operating in a window where a single high-profile incident could freeze regulatory progress worldwide for a decade. And even if the vehicles themselves work flawlessly, there is an entirely separate problem that no aircraft can solve from the air. A flying vehicle is only as useful as the ground system supporting it, and right now that ground system barely exists. For eVTOL air taxis to function as genuine urban transportation, cities need vertiports, dedicated takeoff and landing pads equipped with high-speed charging infrastructure, passenger boarding areas, weather monitoring, and maintenance facilities. China has started building them. Guangzhou and Shenzhen have prototype vertiports operational. But scaling from a handful of showcase pads to a network dense enough to serve millions of commuters is a challenge of staggering complexity and cost. Each vertiport requires urban land, the most expensive and politically contested resource in any major city. Zoning approvals, environmental reviews, community opposition, and construction timelines pile up fast. Then there is noise. 16 rotors spinning at high RPM are not silent. EHang has worked to reduce acoustic signatures, but residents living near proposed vertiport sites have already raised objections in several Chinese cities. Sound is a visceral issue. People tolerate road noise because they grew up with it. A new type of buzzing overhead, directly above homes and schools, faces a different psychological threshold entirely. And the most daunting challenge may be invisible: air traffic management. Today's aviation system handles roughly 45,000 commercial flights per day in the United States alone, coordinated by a vast network of radar, transponders, controllers, and rigid flight corridors. Now imagine adding tens of thousands of autonomous, low-altitude vehicles weaving between buildings. No country on Earth has a proven system for managing that density of urban air traffic. China is developing frameworks, NASA has been working on its own concepts, but nothing has been tested at the scale required. Some engineers argue this is the single biggest bottleneck, harder than the vehicle itself. Subscribe if you want to keep learning about the technologies reshaping our world. And drop a comment. Do you think cities can actually build the infrastructure to make this work? If the engineering challenges were not enough, the company at the center of this revolution carries a financial controversy that still divides analysts. In June 2020, Hindenburg Research, the same short-selling firm that later targeted the Adani Group, published a devastating report on EHang. The allegations were severe. Hindenburg claimed that EHang had fabricated customer orders, inflated revenue figures, and staged demonstration flights to mislead investors. The report cited former employees and business partners who allegedly described a pattern of exaggerated commercial traction. According to Hindenburg, many of the orders EHang publicly touted either did not exist or came from shell entities with no genuine operational intent. EHang denied every allegation. The company called the report misleading and selectively sourced. Its stock, which had been trading above $40, cratered below $15. In the years that followed, EHang slowly clawed back credibility, most significantly through the CAAC type certificate, which many investors interpreted as government validation of the technology and the company's legitimacy. The stock partially recovered, but the shadow lingers. Critics argue that certification proves the vehicle works. It does not prove the business model works. The cost per passenger flight remains significantly higher than ground-based alternatives. Some analysts estimate that a single eVTOL air taxi ride would need to be priced at several $100s to break even, putting it far outside the reach of everyday commuters. For now, the economics work only for tourism, luxury experiences, and niche emergency applications. Whether mass market viability is achievable, or whether the entire financial model depends on subsidies and speculative investment, remains an open and fiercely debated question. And while EHang fights to prove itself, it is no longer the only player in the sky. China's lead is real, but the rest of the world is not standing still. Within China itself, competitors are emerging with fundamentally different approaches. XPeng Aero HT, a division of the electric vehicle giant XPeng, is developing a modular flying car that drives on public roads and converts into a flying vehicle. Their philosophy is different from EHang's. Instead of building dedicated air taxis that require vertiport infrastructure, XPeng envisions a vehicle that is a car first and an aircraft second, eliminating the infrastructure dependency entirely. Their prototype has already completed public test flights and generated enormous interest. Autoflight, another Chinese firm, completed a landmark cross-sea eVTOL flight from Shenzhen to Zhuhai, covering a distance that would take hours by car in just 20 minutes. Their Prosperity 1 aircraft targets longer-range intercity routes, a different market segment than EHang's short urban hops. Globally, the race is intensifying. Joby Aviation remains the front-runner in the United States, backed by nearly $2 billion in funding and a partnership with Toyota. Archer Aviation has secured contracts with United Airlines for urban air mobility networks. In Europe, despite Lilium's financial collapse, Volocopter continues pursuing certification with a focus on the 2025 Paris Olympics as a showcase moment. But China holds a structural advantage that transcends any single company. Shenzhen, the manufacturing epicenter of the global electronics industry, is also the battery capital of the world. The same supply chains that produce batteries for BYD, CATL, and the entire Chinese EV industry feed directly into eVTOL production. Components that take Western manufacturers months to source can be procured in Shenzhen in days. Labor costs are lower, iteration cycles are faster, government subsidies are more aggressive. Some industry observers believe this supply chain advantage may ultimately matter more than any individual technological breakthrough. Others argue it creates a dangerous dependency, one where the West's air mobility future relies on Chinese-controlled components. Either way, the global race is accelerating, and the stakes could not be higher. Step back for a moment and consider the two futures sitting on opposite ends of this story. If autonomous air taxis succeed, if the batteries improve, the infrastructure scales, the safety record holds, and costs drop, the consequences reshape civilization. Urban planning changes fundamentally. Cities designed around cars for a century begin designing around three-dimensional movement. Commutes that take 90 minutes by highway shrink to 12 minutes by air. Property values shift. Suburban land becomes accessible. Emergency medical response times collapse from 30 minutes to 3. Morgan Stanley has projected the urban air mobility market could exceed $1 trillion by 2040. That is not a niche industry. That is a transformation on the scale of the automobile itself. But the other future is equally possible, and far darker. One catastrophic, highly visible accident, a vehicle falling from the sky onto a crowded street, passengers unable to do anything because there are no manual controls, could trigger an immediate and irreversible collapse in public trust. Regulators who approved early certifications would face intense political pressure to reverse course. Investors who poured billions into eVTOL companies would flee. Insurance underwriters would pull coverage or raise premiums to levels that make operations economically impossible. The entire industry, not just one company, but the entire global concept of autonomous urban flight, could be frozen for a decade or more. And history has precedent. The Hindenburg disaster in 1937 did not just end one airship, it ended the entire airship industry, permanently. A single catastrophic, publicly witnessed failure overwrote decades of successful lighter-than-air travel and killed a technology that, by many engineering measures, was perfectly viable. Some experts believe autonomous air taxis face an identical risk profile, not because they are unsafe in aggregate, but because public trust, once shattered, does not recover on a spreadsheet. The next 3 to 5 years are not just important, they are existential. Every flight that lands safely builds the foundation. Every incident that goes public erodes it. And right now, the margin between a $1 trillion future and a technological graveyard is thinner than most people realize. China has placed an enormous, irreversible bet. It has certified a pilotless flying vehicle, built the first commercial vertiports, launched paying passenger routes, and staked national prestige on leading the world into a new era of transportation. The technology is real, the machines fly, the passengers are climbing in. But the question that will define this entire industry was never really about engineering. It was never about rotors or batteries or software. It is about trust. Whether billions of people around the world will look up at a pilotless machine descending toward a rooftop and willingly step inside. Whether governments will hold their nerve when the first serious incident inevitably occurs. Whether investors will keep funding a vision that has never once turned a sustainable profit. The vehicles can fly, that part is proven. What remains unproven, what no test flight or certification or press conference can answer, is whether humanity is ready to let them. And if something goes visibly, catastrophically wrong at the wrong moment, this revolution does not slow down, it stops. If you want more deep dives into the technologies and megaprojects shaping our future, subscribe to Next Blueprint, like this video, and tell us in the comments, would you step inside a flying vehicle with no pilot? We'll see you in the next one.